project team Whiskey Tango. Our name really is just awesome. That's all it is. We basically, the gist of it was we took the Project Tango device and we're curious how it would actually implement into the AEC industry as a whole, given its large amount of open source data that it had, as well as the device itself, all the new sensors that it offered. So we'll be covering that a little bit. Our team as a whole, my name is Matt Van Toor, and Brian Orton, Tyler Davis, Colin Wright, and then the participants who are not here, Mark Pye, because we couldn't pronounce his last name, is actually with Project Tango, so it's great to have him to help us out. Andy O and Court Struckman were just some Googlers that had a lot of information on possibilities of implementation and where we could push this to the next day. So with that, I'll hand it over to, I believe, Tyler to talk about what is Project Tango.
So just, I'll try and go through this kind of quickly because the Project Tango has got a lot to it. But for those of you in the room that haven't heard of it or haven't seen one yet, this is a Project Tango device. It's built by Google, and you're going to go through a couple slides that they gave me to kind of define it a little bit better. Go back one. It says a human scale understanding of space and motion is a pretty succinct way of defining what this little tablet device can do. Go ahead. Doesn't mean anything to us just yet, but let me explain a little bit more. Consider our world, construction world of building buildings, concrete structures. GPS doesn't work very well in buildings, as you know, and it definitely doesn't work when we got steel and concrete moving all around us. So, you know, the Project Tango has a great piece. So go ahead. Here's just kind of a little bit of storyline of to relate it to what we do in our regular life. You know, walk on site, you take in visual cues. Hey, the framer got that wall up that we've been asking him to get up for the past 2 weeks. He finally did it. And we recognize that it's up and, you know, things are there, and we remember that. You know, we remember that it wasn't there yesterday. And then the device into the screen. You know, it's kind of a dumb device. Go ahead, Matt. The camera, you know, says, hey, there's a wall. I have no idea how far that wall is away. I don't know how new it is. I don't know where it should be. You know, hold on, let me check my GPS. Oh wait, it's a 6-sided concrete deck surrounded by steel. We can't use GPS. So it's a dumb device. So in comes Project Tango. Project Tango has 3 key features that I think are key to many things, but definitely the AEC industry. One being motion tracking. It will track your motion through a room, through a large space. Depth perception, it can tell how far things are away, and it will model based on depth perception as well. And then the big piece is area learning. Area learning is, it will remember spaces that it's been in. So if you walk through a space, through a corridor, and there's some great videos on YouTube, check them out. You walk through a space and you come to a point where you have walked before in the past with the Tango, it will recognize that and connect them all together seamlessly. You know, so it remembers where spaces are, where walls are, and it can use triggers too. You know, you could put codes on the wall, like on a column line. You could put a code, and when it sees that code, it will start to build the world and connect the joints together to make it work. So let's keep going. I'm going to move even quicker through this. The sensors to make this happen. There's probably about 5 or 6 sensors on the back of this thing, a wide fisheye camera, a laser for depth perception. Go one more. Let's see, works indoors. Doesn't understand the area around until you've gone through it, right? And the session just restarts every time you start the thing, it's a new starting point. So there's some qualms with the Tango as well. It's smart, but it's still just a device. Works best 0.5 meter to 4 meters, so it's not a long distance, you know, machine. Depth sensor gives us 2.5s out of it. Go ahead. And then I'm going to pass it off to Brian over here about the hack.
Sure. So the problem with, I guess, that we're really trying to summarize is one of the biggest problems I think we face in the AEC industry and just in general. It's not that we don't have enough tools, it's not that we don't know what we're doing, it's that when we start a design and we have plans and we have execution plans and schedules and cost plans, all of these plans, we have this gap that is inherent between those plans and what actually gets built in the field. So we have construction schedules that vary, we have sequencing that may not be per plan. How do we capture any of that? How do we make what we're actually building, the physical product of what we're working on, relate to all these plans, give us the ability to change, adapt, take advantage of opportunities that may exist that we didn't foresee. So we're not coders, other than Colin. Luckily, we had him support us on really just some of the inception of how can we take a tool that really hasn't existed in our industry, this ability to dynamically and on-the-fly capture visual and spatial data, and then start correlating it to those plans. So really it's more for us a process hack. How can we change the workflows of what we do in the construction industry with a new tool? We've always had, well, not always, but we've had laser scanning systems, and they're absolutely incredible, and they're really needed, but they have limitations that keep us from being able to use them on a day in, day out basis, and frankly, put them in the hands of the people that we really want them in. So we got our hands on a Faro scanner here and did a point cloud. Shout out to Faro, or name of your company?
Chet.
Epic Scan.
Epic Scan.
Chet with Epic Scan, for a point of use comparison. So typical total station, I think we've all kind of seen these, but great units, incredible accuracy, but set up on a tripod, you can kind of see the difference that we're starting to look at between these two devices. So in terms of scan, Chet got us set up. It was actually a fairly quick process. I think maybe it took you 5 minutes to set up. With the Tango, we bring it right out of the backpack, and we're scanning in a matter of a couple of seconds to load the app. So with the Tango, I guess, and we'll get into it now. Sorry. So this is imagery of the mailroom. Kind of zoom in on the desk level detail. Go to the next one. So this is the scan out of our total station, the Faro total station. As you can see, you go down to the level of the desk. It is really pristine. We're having great accuracy to the point of, you can see the mail in slots below. It's fantastic. Similar scan with Tango. You can see the point cloud mesh that we've pulled in kind of the same area. So not quite the sort of precision that we're getting from a total station. What's that?
Yeah, we're missing.
Oh, there we go. I'm sorry.
Yeah, no worries. So here's the entire room. Go one more. This is through an app called Voxer. Again, go I think one more. Then we've got the actual mesh file. This is out of Tango's native app. All of the Tango apps are open source. They're free to download. This is via Constructor. It's kind of the native, just packaged up by Google app to do and recognize these spaces. You can see there's a bit more variance in the mesh created through the Constructor app. So what we wanted to figure out is how much does this matter? Is that sort of variance not good enough for what we need to do on a daily basis? And so we started going through and trying to figure out, what are the advantages of both the laser scanner and where would the Tango be a really good point of concept? So obviously, as you can tell, setup time, very good with the Tango. Not so bad with the laser scanner. Really it was pretty easy, it's 10 minutes. UI user friendliness, the Tango, much easier to deploy. It's, who doesn't understand how to, at this point, work with tablets, use these systems. None of us came in with a lot of experience on it. We all ended up using it pretty quickly. There is some expertise needed for the laser scanner. You really want professionals doing this to do it well.
Another real big piece is, I'm not suggesting that this is the actual cost of the laser scanner that we use. We just kind of took an average of the industry, so we have super high level scanner ones that could cost well over $120,000. But at the end of the day, Tango cost us $512, like enough for us to be like, I'm just going to personally buy this because I can see there's value there. The software to use for the two, the laser scanner, they both are effectively the same kind of concept. You have to take it from this type of mesh cloud that you saw into a software you can obviously manipulate or use or whatever type you're pulling out. Free-ish, we say, is just because you go into Blender, which is free, and open source, ish. Then you export it into SketchUp, open it up in SketchUp, which is open source. You can do Ruby scripts for it to begin to manipulate that file as you want. For our actual use, which you'll see in a bit, we ended up taking it into Navisworks so we could immediately compare it, and that was kind of our hack was, I want to be able to use this Monday. I really did want to be able to use this Monday. The other kind of points, the file size, obviously it grows in size as we go. Line work and a couple things like that would be an area you want to focus on. The battery life, you can change the batteries on those. You'd have to charge the Tango, so that was kind of a hit, especially with, you want to do these things quickly. And then the last few pieces are, again, your distance. So Tyler kind of hinted to it earlier. It's really for a room. You're really not going to do a long distance scan with this Tango, which is kind of the ballpark we played into. So we'll just go ahead and jump into what we did. So obviously here on the right we have our laser scanner scan, and we have our Project Tango scan. And you can kind of see what we did was we modeled the space. So this would, for our workflow, would have been, this Revit model in the background would have been what we would have coordinated with all of our trade partners. We would have come into the space and said, okay, I need to make sure that this is what I'm actually selling the owner. So it always sounds funny to say it, but what gets built in the model is not always what gets built in the field. So the first questions we started to ask was, you can see here the orange is the duct. I got a variance here. But does that matter? Like, at the end of the day, is the duct being a little bit lower a big deal? You can click to the next one. However, with my this is a copy obviously, but we pretended it was electrical transformer, thank you. Or whatever, that is not the same size at all. That's a problem. I got an instant red flag. My superintendent goes out there and scans this for 5 minutes, dumps me the file on drive, and I can pull this up in 30 minutes and start to be like, whoa, wait a minute, we got a problem. So that's kind of our instant, how I can take this and implement it to the field. You can see there's, I think you can go to the next one. Yeah, so we started to say, okay, well, how accurate is it really? Let's actually take this to the real world. So the actual measurement of the wall to wall, and we walked in and said, this is easiest for me to measure. But it really highlighted something very fascinating. So 11 foot, 5/8 of an inch off our tape. And then actually in the model it was 11 foot 1. But in our Project Tango scan, you can see we were able to capture the whole space because we're walking around, we're scanning it, we're moving. It's described that you paint the room with this device. The laser scanner, we only set it up once. We said we're going to do one scan with each of them. And with the one setup, you can see right here in the middle of the room to capture as much data as possible. We actually had a variance of 4 3/16 of an inch, and we had a 1/16 of an inch with the Project Tango, which literally we just found that out. It blew all of our minds because these laser scanners are far more powerful, but just the sweep fact that you could just go in, get it, and pull it out as opposed to needing to plan out, we need to talk through everything we're going to get. There's a lot more that goes into choosing by advantage for these two.
There was a little bit of experience there, right? I mean,
Yes.
Either two setups or, maybe we would have put it in a different spot, but because we didn't put it in a different spot, we missed, kind of a chunk of that wall, and now we got a 4-inch variance on the wall, whereas the Project Tango got it. It was kind of amazing little find that we had.
Yeah, one of the things that was really great is like Matt was just saying, with the Tango, you go around and completely paint that room. Through all that motion, which is captured by the gyroscope and the accelerometers within the Tango, still going around the room, there wasn't drift. I mean, those walls didn't come out on you. You didn't have loss of capture with that through the accelerometers. And in the end, got a very, very clean product versus the actual tape measure, which was gave us a good sense of reliability, at least on the Tango point cloud implementation. So ultimately, between the two, it really comes down to what your goals are with your scan, and this kind of leads us into some of the applications that we're talking about eventually on Monday. If your objective with scanning is what we typically used total stations and laser scanners for, super accuracy for planning, let's say, large, installations that need to be down to the 1/8 of an inch, down to the 16th of an inch, you're going to use a laser scanner. You're going to use the total station laser scanner. The Tango's not the right application. If you want to map out the War Memorial Opera Theater here in San Francisco, you're going to use the laser scanner. It's going to do a much, much better job. But for us in the AEC industry, if we want to start capturing more real-time data on actual spatial construction, the Tango starts looking really attractive and really reliable and, Monday ready. So some of the other things we're considering is number of scans and time constraint. If we need that information day over next day, Tango's great, maybe takes a little longer to get a total station scheduled out on site. Distance is going to be a big one. So one of the limitations is that 4 meter-ish long-term range on the Tango. If you need to get higher ceilings, if you need to get large duct or conduit runs or things of that nature that are outside of that range, you're going to struggle finding the Tango to be useful where the laser scanner is going to be perfect.
Move on.
Yeah,
We're getting on. So we did some exploratory things, trying to test out. We put the Tango on a moving device, kind of like a Google car, and trying to capture data like a Google car would. See how accurate it would be. We played with that. The Tango can also be used as a VR device inside a Google Cardboard, which is kind of a cool piece. It's got some flexibility to it. Some of the future uses that we'll kind of demo and we want Colin to talk about a little bit and how he did it and where we think the real power is augmented reality and aerial learning. We were able to take the model that we built in Revit from our coordination efforts, right, and then take it into the new built environment and augment over, and see and walk around in the space. I mean, there's BIM 360 Glue is out there where you can do that same thing, but this is actually, you can move in the space and walk around in the room and take a look, and it's much more dynamic in that way. Some of the things, visual punch list, we're able to, be in the room, and we could say, hey, there's a chip on the wall, or there's a missing thing time. You could tap on you hold it up and the tablet's right there, and now when the trade contractor comes in, he knows exactly where that issue is. You put it on a list, and then he can even augment it if you wanted to, That was pretty cool. We did as-built verification. We talked about that a little bit. Some of even more further down the road, Brian.
Yeah, I mean, you can do things like once you build phases into your Revit model and you've loaded this in and you're able to sync them, then you can stand in a space and sequence through what the future work is. I mean, you usually look back through pictures and see what happened, what was the sequence, but you can now get all your trades guys sitting around a Tango and say, what's going to happen in the next 3 weeks? What's going to happen in the next 6 weeks? And click through, and with this device, you can see that all coming in. It's dynamic, and like you said, with the area of learning, it snaps to exactly where you are and knows where you are, even independent of having to do any sort of manipulation, which means you can now put this in the hands of guys who aren't as tech savvy, maybe your older foreman, maybe, whoever you need to. Material delivery around site, when you know the area, if you connect this to some sort of drive system now, all of a sudden you can have an app pretty quickly built that, will schedule material deliveries that can be loaded up by your stock person, show up to the worker when needed, and drive back when he's pulled everything off.
So why don't we let Colin kind of talk
Yeah,
about how we did that?
Colin.
So we actually have a demo of the visualization stuff. I split my time between this project with these guys and the team that's presenting, or almost presented, but will present next. But in about 6 hours, we put together models that they had constructed, and we put them back in the space to kind of do the checks that they were talking about for correctness, I guess?
Yeah.
And also we built upon some of the example stuff that Google Tango's put together in Unity to create like a tagging system for the space and create issues in that space. And we'll be demoing it in the, what is it, mailroom?
Yeah, mailroom. Come over to the mailroom afterwards and we can show you kind of how it works. But yeah, we can link up a whole bunch of data. The main, for the developers out there, Unity is Tango's got a Unity API, Java API,
Java and a C API.
And a C API.
Unity is unfortunately not open source, and I would have done this in WebVR, but Project Tango doesn't have position tracking yet for WebVR. So as soon as they do that, we could easily have this exact same application running in a browser, not like relying on any third-party application.
Cost-based applications.
Thanks, guys.
Any questions?
Yeah.